This is your standard organic glassware kit. In it you have a number of items. All of them are useful in different ways. So if you have a lid like this, it's got a hole in it, then you use that in conjunction with this. It's called a septum. It has two sides to it. So the one side is rubbery, the other side is smooth. This is a Teflon side. That side faces in. So if I were to put this on a flask, I would put the Teflon side toward the solution. I would have the cap that has a hole in it. That's how these are used. We also do have caps that have no hole. So if you're wanting a solid seal with no hole in it, then you can use a cap that has no hole. When you connect pieces of glassware together, they have a ground glass joint, and they will fit together very nicely, but sometimes this will stick. So I want you to use some grease. This is the silicone grease that some of you had in your NMR samples. You need very little. So I use just my pinky. That's too much, so I'll just use a quarter of what I got. And when these go together, I will turn, making a thin layer of grease. The caps with the holes also have another use. So here's the cap with the hole. I'm going to put it over the ground glass joint here. And now I'm going to use an O-ring. There are two sizes of O-rings here. They're small, and then there's this fatter one here. For this connection I need the thinner one. So I'm going to put that over. And now I join them with the ground glass joint and secure with the screw cap. That's not coming apart now. You've been provided with a heating mantle. You need to get a transformer from T3. The transformer has a dial, and you can turn it to adjust the voltage. That's what transformers do. This heating mantle says on the label that it can only go up to 30 volts. So please do not exceed 30 volts on the transformer. You'll burn up your heating mantle. To place your heating mantle in the ring, insert the wire from above and then make your connection below. Your 10 ml rod and bottom flask should fit securely in the heating mantle. You can also see I've added a clamp, so everything is sturdy and secure. These attachments are where you would add water, coolant water, for your condenser. To attach water tubes to your condenser, you'll need one of these, which is a nipple. You will have to thread it into the sink. Usually hand tight is sufficient. Need to remove it when you're done, because otherwise this powerful jet of water will utterly confuse and baffle honors chemistry. So remove it when you're done. You attach your tie gun tubing to this nipple here. Doesn't have to go all the way up, just snug and secure. And the other end of the tubing will go to your condenser. Common mistake is students want to put the water in from the top, but you put the water in from the bottom. So if this is the vertical orientation, put your tube that's connected to the sink onto the bottom inlet here. And then the top will go plastic tube to the drain. We don't use hose clamps in ACR, just finger tight should be sufficient. When you turn on the water, if you turn it on full blast, the hose will likely pop off. So you're very gentle when you turn on the water. Yeah, that was not gentle. What you want is a slow trickle of water. So if you imagine that being your trickle of water that's going down the drain, that's a good flow rate. We have boiling stones, two kinds. These are what I call black, and these are white. Either one will work. Personally, I prefer the black ones, but they both work. They're on the shelf under the organic acids. So many of your starting materials are located here, organic acids. Cinnamic acid, salicylic acid, benzoic acid are found here. Boiling stones right below that. This particular round bottom flask has a side arm on it. This is going to be convenient for you to monitor reaction progress. You can use a long microcap. We have this size here. These are 4 microliters. They're 64 millimeters in length. And I just got these. These are very long microcaps. These long microcaps have a special feature that there is this plunger which allows you to use these graduated microcaps almost like a Hamilton syringe. Here's the microcap. 1 microliter, 2 microliters, 3, 4, 5. There's a white line up here you can't see probably, but that's 10 microliters. The plunger is small enough to fit inside the microcap. So if you see what I'm doing here, I've threaded the plunger inside the microcap. If I were to immerse this bottom end in a solution and then pull up on the plunger, I could pull up maybe 1 microliter or 2 microliters or 3 or 4 or 5, and this would be fairly accurate. So this is a good way to remove a measured sample from your reaction mixture. When you're done, the microcap itself is disposable, but the plunger is not. So you would take your microcap and dip into the sidearm, get a sample. You can spot that on TLC plate, or if you wanted to do a UV spectrum, you could take a little bit out. It's wise to turn off your transformer when you're taking a sample. You don't really want a boiling sample.